All right, welcome back. We're at it again. We're gonna jump in right with this. We've got a new format, a new layout today. You'll notice that getting a new graphics. I've tried to take this up a notch. I had some students reach out to me and say, "Hey, I like your questions. I really appreciate what you're doing, but they're a little bit easy. They're a little bit easy. And could you concentrate on some more PBQs, some more performance-based questions?" With that. And I said, you know what, we can do that. We can do that. We can take this up a notch. We can make the difficulty a little bit harder. And so we've gone through, and I went in and looked at it and said, you know what, let's start at a medium level, and then we'll work our way up from there. So obviously, still 5 questions. Still going to go through them one at a time. Still going to start off fairly relatively easy, right? It's not going to be like completely memorization questions, right? Like ports and protocols. But we are going to provide somewhat of a beginner level question and then work our way up all the way to a hard question. And I think I've got 2 performance-based questions in these exams now. So hopefully you find them to be a little bit more what you expect, right? So let's jump right into it. I feel like I'm talking too much again. Question number 1: in a network, what is the primary function of a VLAN? What's the primary function of a VLAN? I'll give you a few seconds for this one. I feel like you guys have got this. I feel like you're going to go through and be like, I thought you said you were going to make this hard. Yeah, give me a few seconds, right? And we're definitely we're gonna ratchet it up. I promise you. I promise you. Stick with me. We'll see if we can't get this one done. I'll give you that rudimentary minute to look at it. Remember, we only want to do 45 seconds. 45 seconds on a quiz exam. That's it. Anything more than 45 seconds, we want to guess, and we want to flag it, and we want to move on. That flag is going to be on the top right-hand corner of your screen when you're taking your actual exam. And we don't want to spend more than 30 to 45 seconds per question because we need time for those PBQs. We need time for those performance-based questions as we're going through the exam. That's our goal. All right, let's go ahead and answer this one. If you need more time, you can always pause the video. So in a network, what is the primary function of a VLAN? Let's start with D, to encrypt data between switches. No. VLANs do not encrypt data. That is a misnomer. They don't do that. Can we set it up for encryption? Yeah, we could do that if we want to, but that's not the function of a VLAN. It's not something normally addressed with a VLAN. Let's see. Let's start with let's go with C, to increase the number of available IP addresses. You can technically use a VLAN to increase the number of IP addresses. I mean, you could technically do it, right? And I know some people would argue and say, yeah, I could do this, but is that the primary function? No, that is definitely not the primary function. I would even say that if you're using it to increase the number of available IP addresses, well, depending on its application, that is one of its strengths. I would definitely say that, but not something I would say is the primary function of a VLAN. That leaves A or B. To extend the range of a wireless network or to isolate the network traffic and improve security. Well, if you guessed A, I'm afraid you're incorrect. It is not A. We are definitely not doing anything with VLANs when it comes to wireless networks. Not a primary motivator in VLANs. VLANs isolate our networks. They provide us a capability to go through, and then we can use IP addresses. And what we're really using it for is network segmentation. Network segmentation means that we can remove our network from another network so they're not communicating. We can set it up. We can maneuver it. We can do a lot of cool things with it. But to isolate network traffic and to improve security is going to be our correct answer. There it is, B. B right there. All right, moving on. Question number 2. Let's see if we can't make it a little bit harder. A technician configures port security on a switch to limit the number of MAC addresses learned on a single port. The limit is exceeded. What action should be configured to prevent unauthorized access while maintaining connectivity for legitimate devices? Yeah, we ratcheted it up a little bit, right? A little bit. Let's see if we can't get this one down. I feel like this is a decent question. I wouldn't say it's hard. I would say if you know it, you know it, right? Again, let's move on. If you need more time, of course, you can pause the video. Let's move on. Let's try and knock this one out. All right, we can log the violation. I feel like we could log the violation. I don't think that's going to do what we want it to do, but we could definitely log it. That would be a detective control, not really something that we're looking for here for port security, because if we log it, we're just logging it, right? It's already happened, and we want to prevent it, right? We want to prevent it. So logging is not going to do anything. I think we can shut down the port. Shutting down the port always going to provide us some security. Always going to provide us some security, right? So we could definitely do that. We could make sure that the port is shut down. Of course, then we have the problem of if it shuts down, then nobody has access. And if you read the question, we want to make sure it's configured to prevent unauthorized access, not no access. And so A would not be the correct one. That means we could restrict the port, or we can protect the port. What do you think about that one? If you remember, and see, this is a difficult one. This is a play on words, and I know that, right? So, but again, let's see if we can't knock this one out. The idea that I can restrict a port is always fun, but in this case, I think we're going to protect it, right? We're going to protect the port. This allows the port to discard packets from. We're going to protect the port. This is going to allow the port to discard packets with unauthorized MAC addresses, and it's not going to disable the port entirely. It's not going to do it 100%. This means that we can maintain that connectivity for the devices that are authorized within our network, and so the answer is very much going to be C. It's going to be C. There we go. All right, question number 3. Which protocol can be used to secure data communication between network devices by providing both authentication and encryption, and commonly implemented in VPN? What about this one? I think we can start getting rid of them. I think let's start with point-to-point protocol tunneling, right? Older VPN protocol, supported dial-up networks, right? Definitely something I feel like would be good, except it's an older protocol, and again, dial-up networks. So not really something that we would necessarily use in modern day VPN, right? So definitely not going to be 2. What about generic routing encapsulation? What about GRE, right? We see this in different network protocols and point-to-point connections over the internet, right? Often used with PPTP, often used in that point-to-point tunneling protocol and other VPN protocols, but definitely not going to provide us that secure data communication, right? Not in modern technology. That leaves layer 2 protocol. That leaves layer 2 tunneling protocol, or IPsec, IP security protocol. Well, it's not really a protocol. It's just IPsec, right? So which one? Well, IPsec, we know, is a suite of protocols designed for secure communication, right? It does authentication and encryption, and it does that in a data stream, right? So we know that one. And we know that layer 2 protocol, tunneling protocol, is used by internet service providers, but it doesn't provide encryption, right? So in this case, I think IPsec is going to be the obvious answer on this one, because it does both authentication and it does encryption. So it does both. It's going to provide us a little bit better system in there. And so D is going to be our answer on this one. There we go. There's D. You've been asked to diagnose connectivity issues on a network and run the following command. Based on the output, which of the following is the most likely cause of this issue? What do you think? What's the most likely cause of this issue? What do you think? Again, this is one where a little bit, I feel like it uses a tool output, but I feel like you guys should get this one. I feel like you guys have got this one. If not, then we learned something. And I'm always happy when we learn something. That's always our goal. What do you think? Where do you think this from? I like these types of questions, to be honest. I like being able to do tool outputs, because I feel like a lot of times we know the theory, but we don't understand the actual tools. And so this one really provides us a tracer outlook. And we have all those little stars in there. What do those stars mean? What do you think? All right, let's dissect this one. If you need more time, obviously, go ahead and pause it. Otherwise, we're going to get going on this one. Let's start with D. There is a routing loop causing the connection to fail. I don't think so. I think if there was a routing loop, we would see the reverse, right? We'd see a loop in the system. We don't see that in this. We see that it hits 1, 2, 3, and 4 without any issues, different IP addresses, and then it times out, right? So definitely not routing loop. The remote server is down and not responding to requests. Well, did we get to the server? I mean, we're seeing IP addresses, right? And it kind of cuts off the top, so we really don't know what the actual IP address was that it was trying to connect to. but my guess is not. My guess is not. I don't think that's a legitimate answer on that one. If you were running this command on the norm, you would normally see tracer, and we'd see the IP address up here, and then we can match that IP address to whatever IP address is over here, and then we could find out if it was not responding to requests. But given the situation with the multiple, I'm going to say that that is not happening here. That leaves DNS server not resolving domain name correctly, or the firewall is blocking ICMP packets beyond hop number 4. Okay, it's not DNS server. It's not DNS server. If it was DNS server, then we would see a whole other kind of problem, right? Whole nother type of problem. In this case, hop number 4, we have a firewall blocking it. There's no other explanation for it. DNS server doesn't make any sense on this one at all, because if it wasn't resolved in DNS correctly, if it wasn't resolving the name server, then we would get some type of iteration, and we couldn't even see it based on the tracer packet. We wouldn't be able to see that, right? Well, there's no way of there's no way for us to know if that DNS is linking the name with the IP address properly based on the output that we're given. And so A is the only question, or the only answer that really makes sense on that. So A is going to be a correct answer on this one. A right there. There we go. All right, number 5. Performance-based question. Try to give something a little bit harder on this one. Match the term with the definition. I'm going to give you guys a second on this one. Match the term with the definition. Something I would fully expect to see on your Network Plus exam. What do you think on this one? I feel like I'm going to cut you off eventually, right? I feel like I'm going to do that. You'll notice that this question is probably going to take you a little bit longer than what we normally see. And that's because it is a performance-based question. And so we spent 30 to 45 seconds on each of the other questions. That was our goal, right? 30 to 45 seconds, no longer than a minute. And we cut ourselves off during that minute time on purpose. That way, when we get to these PBQs, we have time. We've got time. We can spend 5 minutes on these questions. I had a student ask me, do I need to do the PBQs to pass the exam? No, you can pass the exam without the PBQs. However, you better get all your multiple choice questions right, because the PBQs are worth more points than a regular multiple choice question, right? So be aware of that. I highly suggest you do not bypass the PBQs. I highly suggest you do not bypass them, right? We definitely want to skip them at the get-go. We want to calm those nerves. We want to go through the process, do the multiple choice questions, and then do the PBQs last. That's my take on it. That's my strategy. But it is definitely something that I would suggest you guys look and work on and go from there. All right, let's answer this one. If you need more time, of course, you can pause the video, right? You'll hear me say that often. So let's do the first one. What do you think? Let's do FTP. FTP. Files transfer between a client and server over the network. It's B. It's B. Look at that. You like those graphics? I know, those graphics are high speed right there. Okay. Yeah, we paid a lot of money for those graphics on PowerPoint. That's how fast those came in. All right, what about SNMP? What about SNMP, right? What do you think about that one? I would say monitors and engages network devices. Let's start with E on that one. So 2 is E. All right, what about DHCP? I feel like DHCP is an easy one. C automatically assigns IP addresses to devices on a network. Definitely gonna do that one. What about NAT? NAT, network address translation, translates private IP addresses to public IP addresses. That means that number 5 must be D, resolves names and IP addresses. There we go. All right. If you found this helpful, I'd appreciate that like, that subscribe, and of course that bell icon. We'll see you next time. Have a good one, everyone.